It's another beautiful day, and we are live for another day. So put a nice smile on that face and enjoy your life. And don't complain about the organic chemistry. In this case, we have a compound that it has two OHs. We want to learn how to name this type of alcohol and also learn some method to produce them technically. And so I'm going to say I have two carbons. Here you go, two carbons, and then one and two on the first and second. I have two OHs. So I go on first and the second. The first and second carbon, I have two OHs, so I go one and two. Ethane, diol. Okay, so it will be ethane, di, and then say ol. Okay, or another way, move. Okay, move the one and two and put them between ethane and diol. And so you can say is ethane. Yes, we have two carbons, and then say dash one and two. And then say diol. Okay. And we also use this term, we use the glycol to refer to compound that they have two OHs. So you can say this compound is made of two carbons, so clearly is going to be ethylene, and then say ethylene glycol. Glycol. And that's another, technically a common name that many chemists use this name to refer the compound with two OHs. Okay, now I have a compound that it has two OHs. Now, where do I start the labeling? Start from from one side that OH get the smallest possible number. So I go from here 1, 2, 3, 4, 5, and 6. On 5 and 1 and 5, I have OHs. So I'm gonna say this is technically okay. This is gonna be hexane. Then I have 1 and 5 diol. Okay, or you can say 1 and 5 hexane, and then say diol. Okay, so you can name it that way, and both names are completely correct. Okay, how about this compound? In this compound, we have another functional group. We have a double bond and also two OHs. And which one is going to get higher priority? Always OH will get higher priority over double or triple bond. And you're going to label it in a way to get the smallest possible numbers for the functional groups. I go 1, 2, and 3. And this compound is cyclic. So here you go, it's cyclic and it's made of 6 carbon. So how about this? We're going to say we have hex, okay, hex, or we have 6 carbons. And next, I'm going to say on the third one, on the third carbon, forgive me, I have cyclic compound, so I should say cyclo. So it's going to be a cyclo hex. And then on the third carbon, I have double bond. So I say on the third carbon, I have a double bond, and I go En. And the first and the second, I have two OHs. So I go on the first and the second, I have two OHs. So diol. Okay, so it will be cyclohex, and then 3-3 En to show position of the double bond, and 1 and 2 is showing us position of the OHs. Okay, how about the second compound? Think about it and give it a try. Okay, very good. So in this case, we're going to say 1, 2, 3. Again, why did I start from the right side? Because OH is supposed to get the smallest possible number. If I start from left side, OH it will start with 4. And so I go 1, 2, 3. This one will be 4, 5, and 6. Okay, and I have 6 carbon. So I'm going to say the main chain, it has 6 carbon. Here you go, 6 carbons. And on the third, the fourth one, I have 2 methyl groups. So I go 4 and 4 dimethyl. Okay, they are attached to what? To attach to 6 carbon. So you say hex, and then you need to show any functional group. Okay, the first functional group that you have is the triple bond. Where is it? On the 5th carbon. So you go YNE to show position, to show actually the functional group or the triple bond. YNE stand for an alkyne, and then we have 2 OHs. So I go on the first and the second one, first and third one, I have OHs. I go 1 and 3. It will be diol. So 4 and 4, dimethyl hex 5 and dash YNE, and to show position of the triple bond, and 1 and 3 showing us position of the OHs. Okay. Now that we learn how to name them, let's practice some chemical reaction about how to produce those diols. And you can use the same technique that we use for ketones and aldehydes. And we know if we reduce the ketones or aldehydes, we will get alcohol. So how about this? If I start with a compound that it has 2 carbonyls, 2 carbonyl groups, and I reduce those 2 carbonyl groups at the same time, I'm gonna get 2 OHs on the molecule. And in this case, I have 2 carbonyl groups, and both of them are ketones. I don't care whether they are ketones or aldehyde. Just simply, I need to have 2 carbonyl groups. Those 2 carbonyl groups, okay, they are sitting on the second, 3, 4, 5, 6. They are, as you see, they are sitting on number 2 and number 6. So I have a 3 here, 4, 5. Okay. On the second one, we're gonna get OH there, and also on number 6, we will get another OH. So this is gonna give us technically 1 and 2 and 7, and we have 2 and 6, my bad. 2 and 6, we have 7 carbons. So I'm gonna say, and 2 and 6, we have OHs and we have 7 carbons, so it will be heptane. And then I say diol. Or how about this? Is a heptane. Okay, heptane, and then we say dash 2 and 6. 2 and 6, we have OHs. So I go diol. Okay, and this is going to be the name of the compound. And thank you very much for watching this short video. Have a great day.